integration by trig substitution. Now, in problems like this, you'll notice that there is a squared minus u squared, a squared plus u squared, and u squared minus a squared in the problem. These come from our Pythagorean identities, such as cosine squared is equal to sine 1 minus sine squared, where 1 is our a and sine square is our u. The same thing comes from the other two are derived in similar ways, except for they are using secant and tangent. This can be applied, or in this one, u is tangent. This one, u is secant. Now, if we do a problem much like this, where it's 4 minus x squared dx, well, this is 2 squared, and that's x squared, so we can do over dx, the square root of 2 squared minus x squared. Now, this right here is u, or a. This is u. So, that means, and we can use the formula u equals a tangent theta. And so, u is x, a is 2, tangent theta. Now, we can take the derivative of this to get dx is equal to 2 secant squared theta d theta. Now, we can move this 2 outside to the front. We can put secant squared theta d theta. And we put that over the square root of 2 squared minus x squared, which is 2 tangent theta, so 4 tangent theta squared. Now, what we can actually do is this 2, we can change to a 4, and we can pull out a root 4. So 2 root 4 times root 1 minus tangent theta squared over secant squared theta d theta. So, well, it's supposed to be a plus. It's a plus. When you're working with tangent, it's a plus. Now, that 4, the root 4 is 2, so that means that 2 goes away. So we should get secant squared theta d theta over 1 plus tangent squared theta. Now, oh my goodness. Now, from this point, we can turn this 1 plus tangent squared theta into the integral of secant squared theta d theta over the square root of secant squared theta, because 1 plus tangent squared theta is also secant squared theta. This turns into secant squared theta d theta over secant squared theta, or no, just secant theta. Cross out that. We have the integral of secant theta d theta. Now from here we can turn this into the integral of 1 over cosine theta, d theta, let u equal cosine theta, or actually we can, with secant squared, or secant theta, we can multiply it by secant plus tangent theta over secant plus tangent theta to get the integral of secant squared theta plus tangent theta, or secant squared theta plus secant tangent theta, theta d theta over secant theta plus tangent theta. Then from there we can let u equal secant theta plus tangent theta, because the derivative of that would be secant tangent theta plus, because the derivative of tangent, secant squared theta. Now when we bring this dun, d theta, when we bring that, we can move that to the other side, and we bring it in, it cancels out with that term on the top, so we just get 1 over u, because that becomes our u. This cancels out with this, which is equal to ln absolute value of u, which is equal to ln absolute value of secant theta plus tangent theta. Now we just have to incorporate this into our right triangle. Since we're working with secant and since we're working with tangent, we set up above, up here, u is equal to a tangent theta. So tangent theta is equal to a over u. So tangent theta, if this is theta, is equal to 2 over x. Well, tangent is opposite over adjacent, so 2 right here, or it's equal to a over u. It's equal to u over a. U over a. So x over 2. So that means that right here, our opposite term would be x. Our adjacent term would be u. This would be the square root of 2 squared plus x squared, or 4 plus x. Now, ln secant is 1 over cosine, so the inverse of cosine, so 1 over cosine, which would be 2 over cosine. Cosine would be equal to adjacent over opposite. So 2 over the 4 plus x squared. 2 over 4 plus x squared. So secant would be equal to square root of 4 plus x squared over 2. And we're going to add on to that tangent theta, which would be already defined over here, equal to x over 2. So we have ln absolute value x plus root 4 plus x squared over 2. And that's how you do integration with trig substitution.